Hi class, this is the last lesson for permutations and combinations. So it's called problem solving. So they give you a problem and you solve. Let's start with some review. All right, so we finally finishing this unit. Recall the following. So these are the formula you have learned. First, we started with fundamental counting principle. You just count for every stage in your task, right? Like you have a task you want to do. For example, you want to order from a menu. You separate into stages. You first order the first thing, then you order the second thing, and every stage you count how many choices are there, and then at the end you multiply them. And then if some of the patterns show this multiplication in decreasing order, you can simplify in n factorial. All right. Not all questions have that pattern. Like some question, for example, the number question, let's say you want to create a three-digit number with only odd digit. The first digit will be 9 because you have 9 choices, 1 to 9. The second digit will be 10, and then the last digit will be 5 because there's only 5 odd digit numbers. So the answer will be 9 times 5 times 10. There's no order here, right? It's not in a decreasing order. Then just do it using the fundamental counting principle. There's no need to think, oh, how is it related to factorial? There's no relation. A factorial is only there when the question happened to have the number happen in a descending order. And then instead of writing out all the numbers, you can just write n factorials. It's supposed to be a shortcut to help you when it's useful. And then same for the permutation notation and then the combination notation, right? You use this when it's helpful. This is the formula that you're going to use. You can punch that in the calculator if it is an exact permutation question and combination question. If it's not, you just use other way to solve it. And then finally, we have this one, the repetition. If you uh, if you need to arrange 10 cars, but 2 of them have the same color, 5 of them have the same color, and so on, you divide by 10 factorial, divide by 2 factorial, divide by 5 factorial. You divide it by the item that's repeat or its identical object. In problem solving, you first start to think is the order matter or not. Then you choose either P or C, and then you solve it. Okay, so let's try it with example. How many arrangement? So when they use the word arrangement, you're arranging something. So the order, does it matter? You're arranging the word puppies, the order matters. All right, so I'll just write order. So it's a P question. Can be made under each of the following question, no restriction. So 1, 2, 3, 4, 5, 6, 7. There's 7 factorials, but what? There are 3 p's. So 3 of them are identical. So there's this types of question, like this one. N factorial over A factorial, B factorial, C factorial. It's a permutation question. If each arrangement begins with a P, okay, well, let's use our um, fundamental counting principle, right? Start with P. How many P are there? Oh, there are 3 choices. Any one of them will do. Okay. After that, you down 1. So after you always start with the restriction. So you start with this one. Now the rest of the question become how many letter left? The 6 letter left. Like you think just like this. So the 6 letter left, you need to arrange them, but there are 2 P because one of the P has been used first. So there are 1 P. So now, however, in here, it must begin with P. So instead of having 3, I would just write 1. Because there's no other choice, it's a P. Doesn't matter which P it is, it's a P, right? It has to be a P. So there's only one choice. Have to be a P. Well, if you pick, sure, there are 3 P's there, but if you just put the 1 there, it doesn't matter. Like the arrangement, the order is P and then something. So there has to be a P. There's only one choice, has to be a P. And then here, the remaining letter, the 6 of them, There are two P, so you divide by this. If all six letters remain are different, then you have 6 factorial, but now you have 2P, so that's the answer. The first two letters have to be P, so your arrangement have to be P, P, right? So it doesn't, there's only one choice. There's one choice there. It has to be P and P. If you swap it, it's still PP. It's still the same thing. So it's one choice. Then if you eliminate the P, you start with just 5. You're left with just 5 letter, and you need to arrange all of them. So it's 5, 4, 3, 2, 1. So the answer is 1 times 5 factorial. D, if all the P's have to be together. So if you group the P, P, P together, and all right, so this is one tile, like one tile when you're playing Scrabble. You need to arrange P, you need to arrange O, I, E. So how many things are there? 1, 2, 3, 4, 5 things. So the question becomes just how many ways you can arrange these 5 things. The answer is 5 factorials. For each arrangement of PPP is only PPP. If you swap it around, it's still PPP, so they look the same. So therefore, the answer is just 5 factorial. If the first letter is P and the next one is not P, all right. So let's try. The first letter is P, so there's only one choice. The next letter cannot be P. You always start with the one with the restriction. If it cannot be P, there are 4 choices. It can be O, I, E, S. There's 4 choices, right? Finally, the remaining 6 letter. Now, you have 2 P left and 3, there's 5 letters left. There's total 7 to begin with. So there's 5 choices left. 2 of them are P, and then there are 3 others letters. So there, to work with this, you have total 5 things to arrange, but 2 of them are P's. So that would be your answer. 1 times 4 times this. All right? So hope this example is a variation of something that we have seen before. And then now just combining everything together, and this is how you think about the question, how you approach a question. So you learn from the thinking and then apply to other similar question. Okay. So let's try example number 2. A class consists of 5 girls and 7 boys. Committee is to be formed. Consists of 2 girls and 3 boys. Determine a number of ways a teacher can choose the committee if no further restriction. Committee question is a combination question. Order doesn't matter. All right. So 5 girls, you choose 2, and then 7 boys, you choose 3. Out of the 10 people, you choose 5 people. So we have seen it before, very straightforward. Johnny, the principal's son, has to be chosen. So there's only one Johnny. So first you choose one Johnny. You can say one Johnny, choose 1, which give you 1. You can just say 1 times. One Johnny, choose 1. Johnny is a boy, so there's only 6 boys left. Out of the 3 boys, you already choose 1, which is Johnny. You're left with 2 positions. So out of the 6 boys, you choose 2. And then the girls is the same. 5 girls, you choose 2. All right? So how many people are you choosing? 1, 2, 2. You're choosing 5 people out of 11 students, right? Only one of them is Johnny that has to be chosen. I think we have seen similar question earlier. Okay? Finally, the twins, Peter and Paul, cannot both be on the committee. Does it mean only Peter or Paul, they cannot both be on the committee? Or none? Does it mean none? Right, it's not very clear. All right. Can you allow no Peter or Paul? Cannot both be on the committee. All right. So let's assume it's either Peter or Paul. All right, maybe that's the question. It's just either Peter or Paul, or it does mean no. Okay. If it's just either Peter or Paul, all right, we can do this either Peter or Paul, which means out of the 6 boys. Okay, so out of the 2 boys, Peter and Paul, you can only choose one of them, right? Either one. Out of the 2 boys, Peter and Paul, choose one, and then the remaining 5 boys, right? The total 7 boys. Remaining 5 boys, you choose 2, right? Because you want 3 boys at the end. All right. So total 7 boys, you choose 3. 2 is Peter and Paul, you choose one of them. And then remaining 5, you choose 2 of them. And then for the girls, 5 girls, you choose 2. Okay. If that's the question, then that's it. If this also means you can have none of them, okay, then you need to plus. You need to plus, right? Remember different case. Here, Peter or Paul or none. It's not overlapping case or like none. Then here, you only have 5 boys to choose from. All right, and then 5 girls to choose from. 5 boys, you choose all 3. Then you add them. All right, the first case is you have Peter or Paul. The second case, you have none. And then you add those combination together. Okay. All right, let's try another sample. Apply to the next class. David, Stephen, and Helen were trying to answer the following question. A student in the class have practice 5 popular and 6 classic music. For the school concert, they will choose a program consisting of 2 and 5. If the order of the composition matter, determine the number of different programs which can be present. The first part of the question, when you read it, sounds like a combination question, isn't it? Right? Out of the 5 popular, you choose 3. Out of the 6 classical, you choose 2. But then afterwards, it says the order matter, right? Because determine of number of different programs. You can have the same set of song, but if you arrange them in different order, it's the different program. So it sounds like a permutation question. So what to do? Okay, the following student, and then they they say, okay, the first one say, oh, there are total 11 books, 11 questions, just choose 5, and since order matter, this is what you do. Okay, of course it's wrong because you have popular and classical. So Steve say, okay, how about this? All right. And then Helen say this one, which the order doesn't matter, which is also wrong. But this is also wrong too. All right. But because if you put it this way, since order matter, you are saying you have 3 popular song first, and then after that you have 2 classical song. The order will be popular and then classical. But then you can mix it up too. So what's wrong? All right. So all 3 of them are wrong. What is the right way? The right way is this question is both combination and permutation. What? Right. Wow, so challenging. What Helen thinking is correct. This is the first stage when you choose the song. Out of the 11 songs, yes, you need to choose 3 popular among the 5, and you need to choose 2 classical among the 6. So let's do that first. Then you're choosing 5 songs. Out of those 5 songs, now you need to arrange them. Between those 5 songs, there are 5 factorial arrangement, right? Like you narrow down to 5 songs, and then you arrange them in order. Different order of them become a different arrangement, different program. You can have another set of combination, and then for those set, you also arrange 5 factorial. So the answer will become that this arrangement, this combination, and then you multiply by 5 factorial. So that will be the answer. All right. So the correct answer is 5 choose 3 times 6 choose 2, right? This is the first stage, selecting the song. And the next stage is arrange the 5 song. Actually, 5 factorial is arranging 5 songs. 5p5 is also the answer, right? 5p5 means 5 factorial. So you see something like this. First, you think in terms of choosing the song. Here you choose 5 songs from the 11 songs. That's the thinking. Now you have the 5 songs. For the 5 songs you have, now you're arranging them. Okay, so that will be the answer. So this is the ultimate challenge in the combination permutation question, which is combining both, in which you need to do both thinking to get the answer. Okay, so try that. That's it for lesson 7. That's it for this unit. Well done.